Converting between part, whole, and comparison. So there's some little thing about more than and less than that comes into play, and how it flips information. So when you have, if the newer compared value is p% more than the reference value, then it's 100 plus p% of the reference value. So if you're paying for your meal plus the tax, then you're paying for a percentage of that tax. But that doesn't mean you don't pay for the meal too. You do. So in order to figure out the tax on that meal, you have to take the cost of the meal and multiply it by a percentage rate, which is the tax. So that would be P times, which is the percentage, times the cost of the meal. We have that value, but then you also have the cost of the meal. You still have to pay for the meal. So you ate the meal, you're gonna have to pay for it. So you have the cost of the meal plus the tax on the meal. So that 100 is the cost of the meal. That's 100% of the cost of the meal plus the percentage of the tax on the meal. That's what the P is. So your value is 100% of the cost of the meal plus whatever the percentage is on the tax of the meal. So it's easier to go ahead and calculate 100 plus that percentage and just do one calculation than it is to do it the old-fashioned way, which is to say, let me calculate what the percentage is of the tax and then add that to the cost of the meal. That's what you used to do in elementary school. But now we're going to take 110%, if 10% was the tax, of the entire cost of the meal and just do one calculation. Same thing happens with a discount. If you get a discount on an item, you go ahead and subtract the percentage of the discount, and then you multiply the cost of the item times the percent that you're actually going to be paying for that item, instead of finding out the percent off of the item. So it used to be that if you were going to buy a shirt that had a 25% discount on it, instead of figuring out what 25% of that item is and subtracting it from 100% of the cost of the item to figuring out what you're paying, now we're going to say, let's just figure out what 75% of the original cost is. Save us some time. Well, that's what 100 minus that P is. That's the 75%. So we want to do the easy calculation, the 75% times the cost of the item, instead of all the other stuff that we did in elementary school to kind of make it make sense to you. So that's where we are going to kind of speed things up. So where it says more than, that means we're adding the 100. Where it says less than, we're subtracting it from 100. So when it says the population of Michigan is 63% greater than, that's going to be 100 plus the 63. So that's 163%. This isn't that difficult, I promise. Population of Hawaii is 52% less than that of Arkansas. So 100 minus 52, that's going to be 48%. The wholesale price of a toaster is 30% less. So that's 100 minus the 30%. That's going to be 70%. The original retail price of a TV is 20% more than its on sale price. Therefore, the retail price is 100 plus 20%. So that's 120 times its resale price, its retail price. A store is having a 25% off sale. The sale price for the item with a regular cost of $120 is $120 times, if it's 25% off, that's 100 minus the 25. So that's 120 times the 75. We're talking about percentages here. That's why I put the 0.75, because I changed it from a percent to a decimal. Because you know you can't put percents into your calculator. And what do you get? $90. And then for the hard one, your total cost for dinner in a restaurant after tip was $76.40. Assuming you left a 20% tip, what was the bill for food and taxes? Our tip was 20%, so that's 120 total that we're going to be multiplying by. And we want to know what food and taxes were. That's what we don't know. So x times 1.20, because it just moves 2 places. Let me clean that up. X times 1.20 is equal to 7640. I can divide both sides by 1.20 and get that x is equal to $63.67. If it says percentage points, it is referring to an absolute change in percentages. 2 percentage points is more than 4%. Is 6%. So the whole percentage moves up. Beware of shifting reference values. An increase of 10% followed by a decrease of 10% does not give you the original value. That's because if you increase by 10%, you all of a sudden have a higher base. This is important for one of your questions in my math lab. If you have a question about that particular question in my math lab, please ask. I am happy to make another video and post it. Don't average percentages. If you have a cumulative GPA, this is also a question, and I believe this actually ends up being a question on the exam too. If you have a cumulative GPA of 2.0 after taking 30 credit hours, in this semester you took 12 hours and got a GPA of 4.0, your new cumulative GPA is not 3.0. Why? Because 12 credit hours does not combine with 30 credit hours. They aren't the same scale. They're not equal. They'd have to be the same scale. Got to have the same bottoms. Just like in comparisons. You have to have the same bottoms. They don't have the same bottoms. So you can't compare the tops. Okay. That ends section 3A, which would put us at 3B. That's what we'll do next time.